Hi class, welcome to another short guided notes lesson. We have finally moved into lesson 3 in unit 8, and the title of the lesson is The Zeros of a Quadratic, and it is a very, very important lesson. Finding zeros of a quadratic function is one of the most important topics in Algebra 1. Now, I know we've just kind of gotten into quadratic functions, but we're going to start to analyze them more carefully and almost, I guess you could say, relate them to polynomials and factoring polynomials. Now, let's begin. I'll read the first paragraph because it is insightful. It says, the x locations of any function where the output, or the y-coordinate, is equal to 0 are known as zeros of a function. Now, these are amazingly important in applied settings. More specifically, that means like when a ball hits the ground after you threw it up in the air, the ground would be a 0, and we can calculate these zeros algebraically. But that's, in a nutshell, what zeros are. So, exercise 1 says, consider the quadratic function y equals x squared minus 2x minus 3. Its graph is right below, and it is a U-shaped parabola. Notice it has a minimum value, and it crosses the x-axis at 2 specific points. All right, now, part A says to actually find the zeros of the function and their x values. All right, we want to actually circle them on the graph and then write them. Now, zeros are where a graph crosses the x-axis. So where does it cross the x-axis? Well, right there and right there. 2 specific points. And generally, quadratics always have 2 zeros. They don't always have to be a positive and negative. They can be 2 positive zeros or they can be 2 negative zeros. In this case, we have a positive 0 and a negative 0. Now, I'm going to write the coordinates of these zeros to start. This first one on the right-hand side, the positive x value is 3. And notice the y value, or the output, is 0. And my negative 0 is negative 1. And notice again the output, or y value, is 0. Okay, these y values will always be zeros. All right, they are the output, and they kind of lend to the idea of that's why we call these values on the graph zeros, because the y value is 0. All right, now the specific x values that we found were x is equal to negative 1 and x is equal to 3 based on our graph. And if you want, I'll highlight these just so you see exactly what I'm talking about. There's our x value and there's our x value, and notice there's our points on the graph, and they correlate with the x values I've written here, x equals negative 1 and x equals 3. Now, looking at my next part of this, it says verify that the positive 0 is correct by showing that y is equal to 0. Now, this is a very simple step here. All we want to do is take my x value of 3, my positive 0, and we want to substitute it into the quadratic function. Now, some may write it as evaluating the function for 3 for y, when in the form of x squared minus 2x minus 3. Which is also equivalent to when we substitute 3 in for both x values, 3 squared minus 2 times 3 minus 3. And now do some quick math here. We've got 9 minus 6 minus 3, which ultimately is equal to 0. And there it is. Our y value is actually equal to 0. So that point 0 does satisfy our equation. It does show that the output will be 0 when x is equal to 3. All right, part C says factor the expression x squared minus 2x minus 3. How do these factors compare to zeros? Now, here is the big, I guess you could say, big idea that we're pushing in this lesson. We're connecting the ideas of factoring quadratics with finding zeros of a function. Now, this is a trinomial, and we would like to factor it into two binomials. Now, if you recall, from about a month and a half ago when we worked on polynomials and factoring trinomials into binomials, we started with both x variables in the parentheses, because when we FOIL them out or multiply these binomials together, we're left with an x times x, giving us my x squared term. Now, if you recall, the second number or the second value in the binomial has to multiply to the last term in the trinomial and add to the second term in the trinomial. And I'll say that again. Has to multiply to the last term in the trinomial and add to the second term in the trinomial. So, my only factors of 3, and it happens to be a negative 3, or negative 1 times 3, or 1 times negative 3. Those are my only possibilities. And now I need to determine which adds to negative 2. Well, 1 minus 3 equals negative 2, and negative 1, plus 3 equals 2. So I know that I'm going to be using these factors of 1 and negative 3 to satisfy my binomials. Now, if I'm going to check this, I'm going to multiply x times x times negative 3, 1 times x, and 1 times negative 3. Well, x times x equals x squared. Negative 3 times x is negative 3x. 1 times x is 1x. Negative 3 times 1 is negative 3. I am left with x squared minus 2x minus 3. I have my original trinomial based on this binomial expansion, if you will, of the trinomial. I'm going to just erase my lines here. And I want to indicate that this is the factored form of the expression or of the trinomial. And I'll highlight it for you as well. Now, the question is, how does this factored expression compare to the zeros? Well, I'll show you. Notice our zeros here are x equals negative 1 and x equals 3. It almost looks as though my binomials are opposite of my zeros. Now I'm gonna just take this information and move it just a little bit down to part D so we can see it a little bit better. X plus 1 was my first factor and x minus 3 my second factor. If I was to set these equal to 0 and then solve for x, I bet you I'd find my actual zeros of my quadratic. Now, setting both of these expressions equal to 0 and then solving, I'll add minus 1 on both sides and add 3 on both sides. And I'm left with x is equal to negative 1 and x equals 3. And would you look at that, those are the exact zeros of my quadratic function. So, what can we say? Well, we can make the assumption that if we factor a quadratic expression or a quadratic function from a trinomial to a binomial, the binomials, once set equal to 0 will indicate the zeros of the quadratic function. Now, I'm going to do this example next, part D, and I'll try to separate everything as best possible. Here's the actual step-by-step process of finding zeros algebraically. Given my function y is equal to x squared plus 3x minus 10, I know that this function can be factored from a trinomial into two binomials. Both binomials will start with my x variable, and my factors of 10, or negative 10 in this case, include 1 and negative 10, 10 and negative 1, 2 and negative 5, and negative 2 and 5. Now, they have to add to positive 3. Thinking back into our polynomial unit, the only possible choice that we could have for both of these binomials that would add to 3 would be a 5 and a 2, and more specifically, a positive 5 and a negative 2. And if you don't believe me, do FOIL. Work your way out of this. X times x is x squared. X times 5 is 5x. Minus 2x is 3x. And negative 2 times 5 is negative 10. Now, I've got my factored form, and again, I'll write it, of my quadratic, and I'll set both factors equal to 0. X minus 2 equals 0, and x plus 5 equals 0. I'll solve for x, and I find that x is now equal to 2, and x equals negative 5. I will highlight both of my solutions, because a solution is actually another name for a 0. And that's it. We can say that my zeros are actually x is equal to 2 and x is equal to 5. And those points, 2, 0, and I'm sorry, it's negative 5, 0, are the zeros of that quadratic function. Now, it asks us to verify this using a table. I'm going to hold off on that for now. But as you know, we're using Desmos.com as our graphing calculator. If you wanted to type this function into the Y1 on your Desmos calculator and then find your table of values, or at least look at the graph, you'd see that it crosses the x-axis at 2, 0 and negative 5, 0. You'd find these points on your table of values, and that would verify that you factored and found the zeros algebraically successfully. Now, that was a quick, brief introduction on what and where the zeros of a quadratic function are and are located. I'm going to hold off on the next part because this is all practicing just solving a quadratic function to find its zeros. And if you look on the next page, it's factoring quadratics and then eventually finding the zeros again using the same process. All right, so just take in what I said today, attempt to fill out the first part of these notes, and that's our first step into understanding zeros of a quadratic function. All right, hope you guys have a wonderful day, and I'll talk to you soon.